Okay guys, let's have a look at today's content. Last lesson we did trig identity. Today we're going to move on to trig equations, which some of the questions we're going to use last lesson's concept. Let's have a look at the first one first. Oops, sorry. First one. Let's start from relatively easier question, then move towards the harder ones. First one, sine x equals -1. And says x is between 0 to 720 degrees, right? So there are two ways I'm going to show you. Sine x equals -1. We can look at the boundary angle diagram on the unit circle, or we can look at it from the sine graph perspective. So if I'm going to draw a unit circle, sorry, it's a bit hard to draw on it. I'll try my best. Okay, so sine x is equal to -1. So the intercepts I've got here is 1, 0, -1, 0, 0, 1, and 0, -1. Yep. And last lesson we said when we represent the coordinates is cos theta common sine theta. Remember that? So which value sine x is -1 is this one here. Right? So that's 0, 90, 180, 270 degrees. Make sense? So we say x equals 270 degrees. However, the question says x is between 0 to 720 degrees. So we're going to have a look at within this domain, are there any other possible values? Yes?
Yes.
So what is it? So basically 270, we're just going to do one more circle. Right? So 270 plus 360. So the answer is going to be 630. Then that's it. That's our two possible answers within this domain. Does it make sense? So I have to look at this question from the unit circle perspective. I'm going to draw another sine graph perspective. Obviously you get the same answer, but just from looking at it from different angle. Excuse me, I've done one side from 0 to 360. I'm going to label that 0 to 360, and one more time, then back to 720, right? And we look at within this domain from 0 to 720 degrees. When sine x equals what? Sorry, when x equals what? The sine x equals -1. So these are the two answers. Just like these are my two answers. So this one is 270. Then repeat for another period. 270 plus 360, 630 degrees. Then we'll fully finish this question. Just two different methods. This is from boundary angle, this is from trig graph approach. Is it all good?
Mm-hmm.
Move on. Next question. Sine x equals 0, pretty much exactly the same sort of thing, right? I just put another question to practice. Sine x equals 0. So we can think that's 360. Didn't draw very well. That's one cycle. That's another cycle. So sine x equals 0. When x equals what? Sine x equals 0. 0, 180, 360, 540, 720. Make sense? So basically 5 answers. So x equals 0 degrees, 180 degrees, 360, 540, and 720 degrees. Basically means when x equals these particular values, sine x equals 0. All good? Move on. Slightly harder. It says find an exact solution correct to the nearest degree. Okay, so sine x equals negative value, and x is between negative 180 degrees to 180 degrees. So what I suggest we do is we're going to sketch the diagram first and figure out which quadrant the angle could be in, and we'll go from there, right? So when I draw this, I'll say, okay, A, S, T, C. Sine x is negative, so which quadrant could be in at this stage? Third and fourth, right? Third and fourth. So third and fourth. And from our basic spatial angle triangle, we know that sine 30 is half. So in terms of my reference angle, it can only be 30 degrees. Does it make sense? Now, if you look at here, if you look at the domain now, this one says x is smaller than 180 degrees, which means from here to here. Well, my angle is not in there, so don't worry about it. And x is larger than minus 180, so it has to be here and here, which is consistent with the third and fourth quadrant. Does it make sense? I'll explain again. So x is less than 180 is in here. Well, my angle is not even in there. Don't worry about it. And x is larger than this one. So which means 0, minus 90, minus 180.
Yeah.
All good?
Yeah.
You okay with that? So 0, minus 90, and minus 180 degrees. Basically means my angle is in the third and fourth quadrant. Now how do I represent my angle? So this first one is minus 30, and this one is minus 150. Are people okay where the minus 150 come from? That's already minus 90, that's 60. Minus 90, minus 60, minus 150. That's how you got it. I'll just write down here. Minus 90 and minus 60. All good? Move on.
What was minus 90, minus 60? Oh, yeah. Okay.
Yeah. Because this one is already minus 90,
Yeah.
and this one is 60.
Yeah.
To get this angle, I rotate from the positive axis
Yeah.
and I go clockwise. Go like that. All good? Okay, next one. Tan x equals minus 3. I'll do the same thing, right? And it says x is between 0 to 360. Usually x is between 0 to 360. But in other questions which we have already seen, 0 to 720, minus 80 to minus 180 to 180, that's the time we'll have to be more careful. Alright, tan x is minus 3. So this time, because it's not special value, right? Unlike this one, unlike minus half the special value in a right angle triangle, whereas minus 3, we'll have to type into our calculator now. Okay? So take our calculator out. Tan x equals minus 3. Can we ignore the negative sign, just type in inverse tan 3, and the way we take the positive negative, that only stands for the quadrant. Yeah, which quadrant? So in terms of value, I'm going to type in inverse tan 3. What does it give me?
71.57.
Yeah, then press the degree, minutes, seconds button. See what it gave me.
71.33.
33. That's above 30, right? So we're going to round up. We call that 72 degrees. People happy? Okay, so A, S, T, C again. Says tan is negative. Which quadrant is that?
2 and 4.
2 and 4. Very good. So basically that's my 72 degrees. Right? That one is also my 72 degrees. Which means my final answer is gonna be What's my final answer? First one is 180 minus 72, right?
Yeah.
So 180.
Another one is 360 minus 72. Yes?
288.
What is it?
288.
288.
108.
What is it?
108.
108. All good? Yeah.
We probably already covered this, but why do we put the 72 degrees in those two places? As in, like,
Because-
why not one of those?
Oh, that just stands for the reference angle.
Yeah.
Because the reference angle is always the ray to the x-axis.
Oh, okay. Why?
That's how the reference angle is defined. Like when we draw the line, it has to be angle here, angle here,
Okay.
and angle here.
Okay.
And these are vertically opposite angles are equal.
Yeah. Okay.
Good? Okay. Next one. Two sine squared x minus 1 equals 0. So it's gonna be 2 sine squared x equals 1. Sine squared x equals half. Sine x equals plus minus root 2 on 2. People okay with that? Now from that, we should hopefully recognize sine what is root 2 on 2.
60.
No.
30.
Oh,
Huh?
Okay.
I don't know.
45 degrees.
40. Yes. Okay.
Okay, those special angle, you need to remember that by now. So x is 45 degrees. Okay? So, based on the value here, we make conclusion x is 45 degrees. Then we draw that. 40. So, if you have a look at sine x is root 2 on 2, which tells me that my base angle or my reference angle is 45 degrees. That's ASTC. And in which quadrant sine is positive? First and second. So that's 45, and this one is going to be 45. So it's going to be 135. Yeah? So two angles there. This one, negative. So it's going to be what? 45. So what's the next triangle? 225. And finally, it's 315. Because that's another 45. How did I get 315? It's 360 minus 45.
Okay. Yeah.
Any questions so far?
No.
All good? Okay, move on. Sine square x plus sine x minus 2 equals 0. Notice that I've taken the 2 to the negative side. To the left-hand side, sorry. To the left-hand side, it becomes negative. Yeah? The reason I do that is I want to have a quadratic. Well, it is a quadratic, right? Something square x, something x, and a constant equal to 0. Is it okay? So we call that net m equals sine x. And suddenly, I've got m squared plus m minus 2 equals 0. Then I use previous knowledge to factorize, I get that. Yeah? Now from here, we say m1 equals minus 2 and m2 equals 1. That should be very straightforward. That's all term 1 stuff. Now, but what does m mean? Stands for sine. Yeah? And I make conclusion, this one is not valid. Because the amplitude of sine is from -1 to 1. This one is -2, it's out of the range already. People okay with that? And m2 is equal to 1, you go back and check the domain. Domain is from 0 to 360. So, where is my, what, x equals what? Sine x equals 1? 90 degrees. Alright, we know sine 90 is 1. Therefore, x equals 90 degrees. It's only one answer. Because this one is not valid. In other words, no solution for this one. Question?
Why isn't it? Oh, because sine never goes to -2.
Yeah, because as I pointed out here, you can see
Yeah.
the range of sine is -1 to 1.
Okay, that makes sense.
All good? People okay with that?
Yeah.
Fantastic. All right. Move on. From here, question get a little bit harder now. Okay. As you can see, oh, look at this one. Just want to compare a little bit. This one is sine square x, sine x, blah, a number. This one is sine square x, cos x, and a number. When I say sine square x and cos x appear together in the same question, what am I thinking? Well, no, not really. I think about sine square x. Whenever I see sine square x, I'm thinking about the most fundamental and really important identity we did last lesson. This one should be sticking on the whole chapter. You're gonna use that in heaps of questions. Okay. Now, because I've got cos x here, the fact I've got cos x here, I'm going to change sine square x equal into 1 minus cos square x, so that I can combine to that term, became a new quadratic. Okay? So I'm going to write down like this: 2, 1 minus cos square x plus cos x equals 2. Just use that identity. This identity is super important. Okay, so far?
Yeah.
Maybe it's a good idea to just watch the notes and listen to the explanation. The reason why we use one note is all of this will be available there after class, right? So don't just busy copy, because I don't want you to miss the explanation part. Now we'll get this now, right? Yeah, that's basic. Essentially, it's the quadratic, and normally we want the coefficient. We want to be monic rather than a non-monic. In other words, we want the coefficient of cos square x to be the positive. So I'm going to multiply -1 everywhere. So 2 cos square x minus cos x equals 0. Then suddenly you've got your common factor as cos x. Right? Cos x is your common factor. Take it out. Then you got 2 cos x minus 1 equals 0. Make sense? And from here, everything is term 1 stuff now. This times this equal to 0, which means this equal to 0 or that equal to 0. Yeah? So cos x equal to 0 or the bracket equal to 0. Sorry about the space, I'm going to write to the right hand side now. So when cos x equal to 0, what does that mean? That means either this value or this value, right? So which means x equals 90 degrees or x equals 270. All good? Now, so for the second bracket says 2 cos x minus 1 equals 0, which means cos x equals half. Yeah? Now, cos what equals half?
30.
That's fine. Cos 60. Right? Cos 60 is sine 30. Sine 30 is half. Yeah? So, you're going to draw that reference angle 60 degrees, right? So, ASTC. In which quadrant cos is positive? First and last. So, what's your final conclusion? 60 degrees and 300. Make sense? This one is 60 degrees, this one is 360 minus 60, which is 300. Then you're done. Okay, it's always important, especially in exam situations, always good habit to make your final conclusion. Therefore, final conclusion is x is 60, 90, 270, and 300. That is your final, oh sorry, let me write it. That is your final answer. All good? Excellent. Any questions so far? Any questions so far? No? Alrighty, let's have a look at this one. This one's a bit harder now. 6 cos x squared x equals cot x plus 8, and x is between 0 to 360. Now, whenever you see for all these reciprocal functions, right, you're going to think about those 3 trig identities which we did in last lesson. Remember those identities? I said sine squared theta plus cos squared theta equals 1, and we divide by sine squared theta, we get what? We divide by cos squared theta, we get what? So those are identities. Now, because the first thing comes to my eye is this one, right? In this particular question. Now I'm thinking I need to relate those identities together. Then we get cosec x is 1 plus cot. So as soon as you see this one, you are thinking about this identity. This identity we did 2 days ago. All good?
Yeah.
So please start to make those connections together. Alrighty, so we're going to come here. 6 bracket 1 plus cot square x equals cot x plus 8. You happy with that? Let's expand brackets. 6 plus 6 cot square x minus cot x minus 8 equals 0. Now I'm going to write in the form of quadratic. Is it okay? Something square x, something x, and constant equals 0. So we know that it's in the form of quadratic. Therefore, we can factorize. Right? How do we factorize this one?
Divided by cot x.
Huh? No, remember that?
The
Cot x is not common factor. We can't take out like that. Just have to be very, very, very careful with those things. Cot x is not common factor. We can't take it out. We have to factorize using
money.
which we did last term. So this is what I mean. These are the like year term skills. You just have to go back to revise if you're not sure how to do it now. Okay, so we get those two. And have a quick check. 2 times 3 is 6. Minus 4 plus 3, minus 1. 1 times minus 2, minus 2. Yeah, so these are the basic skills. Like if you forgot how to do this one in chapter 1, it impacts some of the questions in trigonometry chapter. So make sure you go back to revise. Now, 2 cot x plus 1 equal to 0, or 3 cot x minus 2 equal to 0. So 2 cot x equals minus 1, or 3 cot x equals 2. You happy with that so far? Now, cot x equals negative half, cot x equals 2 on 3. Now, you notice that we are dealing with cot, we're not dealing with tan, right? So, it's better to change into tan, which we are more familiar with, rather than this reciprocal function. So, because cot x is negative half, what does tan mean?
Negative 2.
Very good. And this one, tan x is 3 on 2, just reciprocal. Then becomes one of the questions we did earlier. Okay, so I'm going to ask you the same thing, type into a calculator, but don't do the negative. The negative just tells us which quadrant it is in, but just typing inverse tan 2. What does it give you? Approximately to the nearest degree, shall we say?
63.
Okay, let's go 63, fantastic. Okay, 63, ASTC. Because it's negative, right? Negative means the second and fourth quadrant. So this angle is 63 degrees. This angle is 63 degrees. And this angle is also 63 degrees. So what's my final answer? My final answer is not 63, my final answer is this one. Right?
Yeah,
So 180 minus 63, which is 117. You okay with that? Sorry, not enough space. I'm going to have to keep pushing down a bit. So theta, sorry, not theta, x. X is 117. What's the other possible one? 297, fantastic. 297. So these two answers are done for this angle, right? Or for this particular situation. Now there's another situation we have to look at is tan x equals 3 over 2. Do the same thing, type into the calculator. 56. And we'll look at ASTC again. ASTC. Tan is positive, which tells me the angle has to be in the first and first and third quadrant. So 56 and 180 plus 56, right? So x is 56 degrees and 236 degrees. Like that, your answer is combined 1, 2, 3, 4. 4 possible answers. People okay? Okay, I do apologize. Today we have a lot of examples I just want to go through. Let's keep moving. Hopefully we're not too tired yet. Next one. Cosec x is minus 2. We want to find x. Remember we said when we see these reciprocal functions, we're thinking about the original function. What's the reciprocal of cosec? Sine, very good. So when I see this one, I'm thinking about sine x equals negative half. All good? Okay. Now, because it's special value, right? Exact special value, half root 3 on 2, right? So we don't have to worry about typing to calculator, right? Because we are familiar with those angles already. It's in the negative. Sine is negative, which quadrant? Third and fourth. I think we did one of those questions earlier. I think we did that. Yeah, we did one of those questions earlier. So, 30, yeah, we actually did. So it's minus 30 and minus 150. Sorry, it's one of the double repeated question. Okay, next one. Sec is 0.7.
Wait, Aaron, sorry, you Yeah.
One of the questions we did a bit earlier. Okay, sec x is 0.7. X is between minus 80 to 180. When I say sec, I'm thinking about cos. So cos x, that is 7 over 10, right? So
Yeah.
cos x is 10 over 7. What did you notice? When I say cos is 10 over 7.
It's a whole it's a positive number, I guess.
Yeah, but what did you notice?
Fraction.
It's a fraction. More than that, what did you notice? Think about the range of a cosine graph.
It's not on a cosine graph, it's more than one.
Perfect.
Yeah.
So, no solution.
Oh yeah.
It's not possible.
Oh,
Right?
it's fun.
We keep saying that sine and cos, the range is from -1 to 1. This one is already bigger than 1. Yeah? So, no solution.
Oh, it's hard.
Happy?
Uh-huh.
Alright, I'll cover some of the other examples, then I'll come back to this one. Okay, few more. Okay, equation with compound angles. Basically, compound angles is not x anymore. It's 2x or multiples of x. Making something up. So tan 2x is root 3. X is between 0 to 360. Let's have a look. I've noticed that I've got 2x and I've only got x here. So immediately I'm thinking about I need to change the domain. Okay? So what does that mean is, alright, so x is between 0 to 360, that's all good. But I'm working with 2x. So I'm going to change the domain to 0 to 720. People happy with that? Why is that? Yes, question says x is between here and here. But I'm dealing with 2x. Therefore, 2x have to be between 0 to 720 degrees. Okay, and the way I approach this sort of question is, alright, I'll say, okay, what is my related acute angle? So, related acute angle, in this case, is 2x. 10 what is root 3? 60 degrees. Those things I keep saying, exact value in a right angle triangle, we need to remember that almost by heart. And it's not hard to remember, just draw that, then you have that. Right, this sort of information you almost need to visualize in your head, right? Okay, related acute angle 2x equals 60 degrees. Now, in this domain, up until here, are there any other possible situations?
What?
Okay, 2x is 60 degrees, right?
Yeah.
Now, in this domain, 10 what else is positive? So, ASTC, we've talked about this one, that's 60, right? And in third quadrant, 10 is also positive, which means 240, right? So 2x equals 60, and also 240. Because the domain has been extended into 720 degrees, there will be other possibilities. So I keep adding, how many? It's 360. So it's 360, those are my two confirmed ones. So I'm going to keep adding 360 to this, keep adding 360 to this.
Until you reach 720?
Until we reach 720. No, I mean, not exactly 720, but within the domain, not outside.
Yeah.
So, 420, 600. You can't go anymore. Once you go more, it's already outside the domain. Then we don't care anymore, right? Now that's 2x. But are we interested in 2x? We're still for x, but not still for 2x, right? Then we go back. Now we need to go back now. How do we go back? Divided by 2 everywhere. Yeah, you see that?
Yeah.
We're going to divide it by 2 everywhere. So, x is 30, 210. Sorry, not 210. Not yet. Moving a bit fast. 120, then 210, and then 300. Then you got your all possible answers. Okay, I'm going to do a final one, then we'll finish for today. This one. Now you can see, normally just sine x, right? Sine x equals whatever, whatever. But this one is not sine x, this one is x minus 250 degrees. And x is between here and here. The first thing, just like the previous question, right? What did I do with the previous question? The first thing I did was change the domain. So I'm working with the new domain, then I go back. Yeah? Same thing here. That is my old domain. But I'm looking with this one. So I'm going to minus 250 everywhere, in other words. So x minus 250, minus 250, minus 250. That is the new domain we are working with. Is that okay? Why is that? Because of this. Because of that part. All good? Now you ask yourself, what's my related acute angle? In other words, sine what is root 3 on 2? Okay, those things should be in your head.
60.
Good. Related acute angle. In this case, x minus 250 is 60 degrees. So 60 degrees is the reference angle. In other words, we are doing. And we're going to have a look at the ASTC again. ASTC. In which quadrant sine is positive? First and second. First and second is positive, right? Now, if you have a look at the new domain we are working with, smaller than 110. Which quadrant is smaller than 110? First. Only first. 110. This one's already 180.
Why?
Because
Well, 110 is x is 090, 90 to 100, right?
Yeah.
But if
So-
you made 20 degrees into the second quadrant.
Yeah.
so then what?
Yeah, but hold up. So this one is 60 degrees, right? So what we're going to do is we say x minus 250 is 60. Oh, sorry, I've already written that. Just go back. Okay, so let's have a look. This one is x equals 310. Yeah? But in this domain, where are the other possible values?
Everywhere. Negative 50.
Not 50, but yeah, close. So if you think about like that, that's where is this?
Oh,
Where?
yeah.
Sorry, let me highlight. Where is this part? Where is greater than minus 250?
You can have that.
0, minus 90, minus 180. Where is minus 250? Here.
Yeah.
Here. Yeah? So what's that angle called?
240.
Minus. Correct. Minus 240. Very good. So you see here, minus 180, because the angle is 60 degrees, right? 60 degrees. That's our base angle. So this one is also 60 degrees. Minus 180 minus 60 is minus 240. Minus 180 minus 60 is minus 240. People okay with that? So these two possible values is 60 and minus 240.
Yep.
So how do I solve for this one? X minus 240, x minus 250 is minus 240, x is 10 degrees. Then you finish. Your final answer is two answers. It's 310 and 10 degrees.
Yep.
Okay, before we finish, in conclusion, change the new domain first and look at, in the new domain, what are the reference angles? 60 degrees. You do this part first, 60. And do this part, minus 240. Then you go back to solve that, plus 250, plus 250, then you're done. Alrighty, it is quite a lot of work today. I think our brain is pretty tired. Let me just finish here. How is it?
Okay.